Hello all. In this video we will be talking about the limit definition of the derivative. So thus far when we've talked about the derivative, we first defined it as this instantaneous rate of change, right? So versus an average rate of change. And this just meant, right, you're thinking about like velocity is your common example. So it's exactly how fast you're going at a specific moment in time and not what you're averaging over a period of time. And another definition, more geometric one, is the slope of the tangent line, right? So if I have a graph like this and I want to know my derivative, and remember if this is f of x, the notation we would use is f prime of a would be the derivative at a. And this would mean, in this case, I look at the tangent line, so the line that just glances on the graph near there, looks like this. It would be the slope of this line, right? So f prime of a is the slope of this line. So these are the definitions we have thus far. And so what we're going to talk about is how to interpret this in terms of a limit. Because this seems a little bit challenging, right? Because when we do slope, we're used to doing, rise over run, or like your y2 minus y1 over x2 minus x1. But I only have 1 point here. So how do I talk about slope if I don't have 2 points on my line, but only one that I know? So to talk about the slope of the tangent line, we first need to think about the slope of a secant line. So for the secant line, right, we'll be talking about 2 points here. So again, this will be f of x. So we have the points at f of a and f of a plus h. So it just means this gap here between these is h. And the secant line then is just the line that goes between these 2 points, right? And so the slope of this line is pretty easy to calculate, right? The slope is the all familiar difference quotient, right? So the a plus h and a there, we get some cancellation and we get f of a plus h minus f of a over h. So we've been practicing with the f of a plus h minus f of a for exactly this reason. It's going to show up a lot. So this is the slope of that line. So then how does this help us find the slope of the tangent line? All right, so now let's see how we get the slope of the tangent line. So our goal here is to find the tangent line to a so that we could, compute f prime of a, for instance. So the idea is, well, we've got this secant line, but this isn't a very good approximation, right, of my tangent line. Right, my tangent line's in red here. And so I don't think their slopes are very close, but I can shorten this gap, right? So I can take a point here, make h smaller, and then take the line through those, right? Make h smaller, okay, that's better, but still not that good. All right, I make h even smaller. And then I again take another line through, and I'm getting closer. And so the idea, right, is we make h smaller and smaller, closer to 0. And that's basically shrinking this gap. And so you're taking points closer and closer together to determine your slope of the secant line. And if you take the limit, right, this is why we have introduced limits here, then we're going to get the slope of the tangent line. Right, so just to have that written down, the limit as h approaches 0 of the slopes of these secant lines is the slope of the tangent line. And so now we can actually give the limit definition of the derivative, right? We know what the slopes of the secant lines were. Those were f of a plus h minus f of a over h. And we said the slope of the tangent line should be exactly what we get when we take the limit as h approaches 0. And so we say f is differentiable at a point x equals a if f prime of a exists, right? And we talked about this before, and we said, like, if f is locally linear at a, which makes sense now, right? Because we're talking about slopes, and you need to be looking like a line if you zoom in to talk about slope there. And for this, right, we're just looking at, okay, does this limit exist? And this is how we connect those two notions. So let's look at an example where f is not differentiable. So here's the graph of the absolute value. And notice, right, if we would zoom in on this point forever and ever, it's always going to look like a v. It's not locally linear, so it shouldn't be differentiable there. Let's see that this actually works out with the limit definition. So f prime of 0, right, would be the limit as h approaches 0 of the absolute value of a is 0 here, so 0 plus h minus absolute value of 0 over h. Okay, and that, of course, is just the limit as h approaches 0 of the absolute value of h minus 0 over h. So how do we look at this limit? Well, it's a two-sided limit, so we should think about the limit from the left and the limit from the right. So the limit from the left of absolute value of h over h, well, we're plugging in small negative things. Well, what happens if we plug in a negative thing to the absolute value? We switch the sign, so we get negative h over h. Limit h approaches 0 from the left of negative h over h, and that's just negative 1. And then if we plug in small positive things, well, the absolute value does nothing to it. So the absolute value of h is just h itself again, and we get 1. And so the point is, of course, these guys are not equal. And if my limits from the two sides don't match, then this limit does not exist. And so f is not differentiable there. So the last thing we're going to do is look at the derivative as a function. So this far right, we've only looked at one point at a time and talked about the slope of the tangent line. But you can also talk about the derivative as a function where you can get the slope of the tangent line at all the points, right? You can just plug in different x to get the slope at that x. And this is how you do that. You just put in x for a, right? A was a constant, x is a variable here. So let's do an example with a linear function. So let's let f of x be, say, 4x plus 1. So naively, if I'm just thinking about intuition, I know nothing about these limits, I'm thinking this is a line with slope 4. The tangent line should just be the line. So I should get 4 as my answer. So let's see what happens. So f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, fill this out. All right, I get 4 times x plus h plus 1 minus the quantity 4x plus 1. So this is 4x plus 4h. So my 4x's are going to cancel, my 1's are going to cancel, and I just get 4h over h, and that's just going to be 4. And now for your exercise, I want you to look at this function, and we're just going to step-by-step compute the derivative using the limit definition here, okay? So it's just kind of step you through this process, and you have been well prepared because you've been dealing with the difference quotient quite a bit already. All right, thank you for watching.